Good morning, good afternoon, good evening, everybody. My name is MC Brown. I am VP of Product here at Continuent, and today we're here to talk about replicating data into Redshift. Before we get started, a couple of administration points. So first of all, this webinar is being recorded. If you want to watch this webinar again at any point, you'll be able to go and find it on our website and on our YouTube channel, as indeed you can with all of our previous webinars and training. Also, if you would like to ask any questions while this webinar is on, please go ahead and do so. You should find a little question panel within your GoToWebinar panel as we're doing here. If I have time at the end, I will certainly answer any questions that come up. If I don't have time at the end, what we'll do is we'll collect all of those questions and we'll make a blog post about them so that you're able to see the answers and get the answers to your questions. Obviously, you can contact us anytime as well. We're always happy to help. With those two pieces of admin out the way, let's get started. So, today what I want to do is I want us to be talking here about Redshift. What can we do with Redshift? Why would you use Redshift over other environments? How do we get the data into Redshift? What that looks like? We'll also have a look at a couple of extra things that we can do with Redshift that we're not able to do with some of our other replication environments, largely because of the environment that Redshift offers us and what we're able and possible to do. And we will also have a look at one of the particular tricks, something that we've added into the new 5.3 release of the Redshift applier and of the replicator in general. We'll have a look at how we can use that to replicate data into a single schema, which is very useful in a typical analytics environment. And we'll also have a look at what we're doing with the Redshift applier, what we're doing generally with the analytics and the replicator as a whole. Now, first question to answer, right? Why would you be using Amazon Redshift? Well, the great thing about Amazon Redshift is a column-based data analytics store. It's an Amazon service, right? It's an Amazon database service. It's very, very easy to fire up, very, very easy to expand and shut down. It's cluster-based, so obviously you can size it according to your needs. If you find that your data size or your data complexity and the speed at which you need your queries out, you can obviously increase the number of nodes. You can create a cluster, according to your ultimate requirements. Also very easy ultimately to shut down, right? If you want to fire up your Amazon Redshift instance, put some data in it, perform your analytics and shut it down so that you keep your costs down, that's certainly something that you're able to do. The other thing about Redshift is ultimately it is a database service, right? It is database as a service. So once it's up and running, in order to use it and to be able to get the best out of it, you connect to it using just a standard Postgres JDBC interface. You can also obviously use ODBC, but you're able to connect to that because it's Postgres. You can run whatever queries, etc., that you want to be able to run, directly on your service with ease. I mean, it's a standard SQL environment. You're able to do everything you want to do. It is incredibly easy to access because of this, right? Once the instance is up and it's up and running within your Amazon environment, you can just connect using any Postgres, compatible client. And also, an important point, and particularly for us from the perspective of obviously how we're able to get the data into the system, is it integrates very, very nicely with the other Amazon components, and in particular S3. So you want to get your data up there, you get the data up there through S3, and that makes it very, very practical for accessing and using and making use of that information. Overall, what do you use Amazon Redshift for? Well, I mean, it's an analytics platform, column-based store, analytics platform, very, very good at, aggregations, very, very good at analytics at large volumes of data where you ultimately want to pin out. Maybe you want to perform an average or a sum of the total number of sales and an average of your sales, or maybe you're having a look at, sensor data and you want to get, information averages on all of the information that's been written in. What's the average temperature of this over the last day, the last week, the last month? Maybe you're using it for logging data. You want to identify errors. Maybe you're using it for microtransactions, and you want to be able to sum those microtransactions up at the end of the day and say, this is how much I need to bill this customer. You know, all of these different things are available. The great thing about Redshift is that because it is a big clustered, you know, column-based store for taking all of that information in, it is incredibly quick and efficient to be able to perform those analytics, and it is incredibly quick to be able to get that information and ultimately use that. You know, we have customers who are using this, and they are using it in a live environment, right? They are actually writing that data into Redshift, and the data that has been written into Redshift, they are almost immediately then using, you know, to be able to provide statistics and information out to their customers. So that's how practical it is, and how useful it is. The big thing, obviously, is that you know, Redshift is not really a transactional database. It's not a database where you would write your typical small data in. So ultimately, you're going to need to get your data in from your transactional store, and you know, that's hopefully where we come in. We're able to replicate the data from your transactional store for you into your Redshift instance. So how does that work? Well, you've attended any of our other webinars. You know, some of the basics of this are not going to be new to you. There's not anything here which is largely different on the extraction side for how that data gets out of the databases. What is different within a Redshift environment is, you know, there are some differences in terms of your actual deployment. So, you know, typical replication deployment, you have an extractor which is reading the data out of the source database, and you have an applier which is ultimately applying it into the target database. Often you would put those different components onto the database in question, and onto the servers that are running the database. With Redshift, we can't do that. Redshift is database as a service, and so we don't actually have access to a machine onto which we can do it. So for a slave replicator, the slave replicator can either be you know, on your machines, on your servers, whether that's EC2, your own on-premise, and we ultimately then use that machine to write the data into Redshift. So we're not on the Redshift server directly, but we are actually kind of off-board, being able to write that information in. But the rest of the rest of the topology is the same as it has always been, right? You have a master replicator which is extracting the data. You know, and as we know, you know, we have two different modes for pulling that information out. Oracle, we use the redo log. We extract that information from the redo and the supplemental log. We pull that information out and put it into, you know, our own format, which is the THL, which contains all of that information, that transaction history log of all of the changes. On MySQL, or indeed Amazon RDS for MySQL, we are pulling the information out of the binary log. And again, we pull that information out, and we pull that data out and put it into THL. So these are row-based events we're pulling out in this case. We pull out those row-based events, we put them into our THL. As part of that THL, the THL obviously contains a bunch of metadata. So, you know, one of the things is every single transaction that we pull out, and we always pull out entire transactions all the time. Every transaction that we pull out and give it a unique event ID, which we use a little bit later in the Redshift process. We also, you know, pull out obviously the original commit time, a bunch of information, as well as actually the raw row changes that exist over on that side as well. When it comes to the Redshift side, in order to get the data into Redshift, first of all, we have to get the data into S3. And what happens is we use our batch applier systems. Now, the batch applier is a system that we actually use for a number of our different appliers. And this basically takes the information, the incoming transactions, and you get to choose, you know, your combination of latency and obviously, you know, ultimately really performance in terms of loading that data in. You can set the batch to operate every 5 seconds, or you can set the batch to operate every 100,000 rows, or you can set it to act on both. You know, so in 5 seconds, we're going to generate a CSV file every 5 seconds, and that CSV file is going to contain the information for one table. So obviously, if there's multiple transactions across multiple tables, we create multiple CSV files. That CSV file contains the original transaction data, also contains some of that metadata, so it also contains an event ID, also contains you know, the commit time, and it also contains an indicator of what the actual event type was, right? That is, you know, it will tell us whether the operation is an insert, an update, or a delete. All of that information gets written out into that CSV file, you know, alongside obviously the actual change data that we're writing out. All of that information ultimately gets uploaded to S3 because this is the way in which we can import this CSV information into Redshift. And then we import that data into Redshift, and I'll look in a minute exactly what we do with that. That process, that batching process, you know, like I said, I mean, it happens every 5 seconds, every 30 seconds, whatever you configure it, or every 100,000 rows. You have to be aware with a batch applier, and particularly applying into data analytics, you want to try and, you know, time your transactions and your apply process accordingly, right? Because you know, you could set it every 5 seconds, but that might mean you're only loading 1 or 2 rows into the target system, which is not necessarily a problem, but it's not necessarily efficient. Loading data into an analytics environment like Redshift, you know, you are much better to be able to loading 10,000 rows, you know, 100,000 rows at the same time. And in general, you know, in my own testing, I can load 100,000 rows into Redshift at about the same speed as I can do, you know, 5 or 10. Just because this is what it's designed to do. It's a data warehouse. It's an analytics platform. So, you know, there's always going to be this trade-off. You want the data in there as quickly as possible. You want to make the best use of that data. You know, again, we work with customers, and sometimes you end up kind of adjusting that. Yeah, we want the data in very, very quickly, but you know, if we do it too frequently and in too small chunks, we end up, you know, creating a lot of tiny imports, which actually overall may slow the entire process down. So it is something that you have to look at. Now, in terms of what actually that looks like in terms of writing that data into Redshift. So, you know, what we do is we take that data, and as I said, I mean, it's a CSV format, tells us whether it's an insert, tells us whether it's a delete. In actual fact, the default mode for Redshift is that, you know, inserts are obviously inserts, deletes are deletes. Updates are modeled as a delete followed by an insert, because that's essentially what an update is. And that's something that can be very, very easily and quickly processed. And that gets loaded up into what we call a staging table. That staging table contains that structure for the information. All of that metadata, as well as the row data for each table in each case. And once it goes into that staging table, then we actually perform this materialization process. And the materialization process basically says, let's delete everything that's marked as a delete, and then let's insert everything that is marked as an insert. So obviously, like I said, updates are modeled as a row for deletes followed by a row for inserts. And what we do is when we perform the insert, we actually say, perform an insert using the latest version of the insert according to our transaction, right? So we have our unique THL event ID. So we know that each THL has got a, you know, a sequential number attached to it. And so we can say, even if a particular row has been updated 10 times over the course of this one batch, we know what the most recent one is, because we know that it's going to be the one with the highest transaction ID. So we perform that insert that latest insert that latest process and upload it, and now we have what we call our base table, which is the original carbon copy of the information from your source environment. So you have this staging table data that goes in, and then it materializes into this base table data. And the replicator is handling this entire process for you, right? The replicator generates the CSV file. It uploads the information into S3, which, as I said, this is the only way in which we can do an import into Redshift. We upload that data into S3 using the S3 utils. So we're using a basic method of generating the CSV file, uploading it into S3, into your designated S3 bucket. When you pull that information in, we import that table into Redshift, and then we materialize that imported staging data into the base table. Hey presto, you've got a final table with all of the information in. Now we can do a few additional tricks as part of that process with Redshift. So obviously, when we're moving the data up and we're putting the data into CSV, and then ultimately putting the data into S3, and then being able to pull that information out, you can see that there's kind of a whole process going on behind here. But you can also see that potentially some of this information is going to be useful. So that CDCD data that we have created, you know, these CSV files that contain this batch of information, that you know, contain information on all of the changes, all of the deletes, all of the inserts, etc. we can actually, within the Redshift environment, we can actually keep that CDC information for forever, effectively. Long-term CDC collection, we record and keep all of that CDC data for all of that time. The reason why that is useful is obviously you can look at that CDC data over time and use it for a variety of reasons. We have customers who have been using that CDC data, and maybe they are resetting the information within their database, you know, back to a previous version. You know, they'll go in and have a look at the CDC data, you know, and kind of collect it together and say, okay, you know, for this batch of information, what was the latest insert? What was the latest setting for each of this information? You know, you could use this for, you know, I don't know, a sale, for example, at of products. You want to reset the data back to a previous version. That's obviously one thing that you can do with that CDC data. We have other customers that are specifically looking at, you know, the historical changes. So if you're writing information in and you're updating data within your transactional database is typically going to contain the current, the active version of the information, but that's not the historical data. So, you know, again, I mean, let's have a look at the product and have a look at the sale. Imagine that you are, you know, you've set the price of a particular product and you want to go in and have a look at it. Well, if you go and have a look on your transactional store, it's going to contain its price right now. It's not going to contain its historical price when maybe you offered it on sale, maybe you got a special deal from the manufacturer, and so you lowered the price. You know, all of these changes that are over time. You know, over the course of a month, a year, etc., that information might change. Well, if you tracked all of that information because it's in the CDC data, and you've got a long-term copy of that, through that CDC information and say, show me what the value of this particular product was over time, and pull that information out. And all of that information is available within the long-term CDC data. And that enables you to go in and have a look and obviously understand things like understand trends, understand you know, organization, understand how this how the data is being used and what it looks like over a long period of time. Now, the other thing that we can do is we can obviously compress the data before we upload it into S3, and this is something that you have to be careful of, and it is something that you would have to examine, right? So you know, compressing the data obviously makes it smaller, and that ultimately uploads it to S3 quicker. So if you have a look at the overall replication process, you have to remember that it's possible for, you know, if any latency, any delay is going to be introduced into the replication process, it's going to be the point at which you're uploading data from your local machine or even your machine within EC2 and moving that data into S3. You know, that's the bit that probably takes the longest amount of time because you're relying on an external system to be able to cope with that. You can compress the data first, and that will speed up the time it actually takes to upload the data into S3. But ultimately, you have to think about the trade-off. I mean, compression is something that, you know, takes your own computing resources, takes its own amount of time. You have to kind of trade that off against how long it's going to take to, in terms of uploading it and what kind of a difference it's going to make. However, look at it from the perspective of if you combine that with the long-term CDC collection, it might make sense to be compressing that data before you put it in S3. And also remember that if you're uploading a lot of data into S3, you're charged by how much you are uploading, and also charged by how much you are ultimately storing. And so compression, therefore, has a, you know, a different element, a different semantic that you might want to be aware of. We can also decide whether you want to clean up that CDC information. So the active CDC, that is the data that is actively being used in order to update and create the table. Do you want to clean up those files or not? This is completely separate from the long-term CDC. So the long-term CDC actually copies the contents to another area. The CDC cleanup says the ones that I'm actively using, do I want to delete them after I finish doing the import or not? And that's something that you may or may not want to do. Maybe you want to keep it for a little while before you ultimately clean it and manage it yourself. That option is available. All of this is configured within your Redshift deployment. Now, the last two items are actually new in Tungsten Replicator 5.3. I'm going to go into a bit more detail in the next slide about what single-schema replication is. And the next item, DDL translation. So historically, you know, when it comes to replication of data, what you do when you set up the replication, if you have existing tables, is you use our tool, which is called DDL scan, and DDL scan translates your existing table data and ultimately creates suitable tables within Redshift to match your source table so that you can start doing the replication. And that's fine, but what that process didn't do is it didn't handle what happens if you change that table structure on your source database, right? So, you know, you add a new column, maybe you delete a column, you change the column type, etc. You know, that's something that we didn't handle. DDL scan was a one-time shot at performing that particular change. We're now able in the new version to actually translate DDL from the source environment, so from MySQL initially, and ultimately we will be handling it with Oracle as well. But from MySQL, we're able to handle that DDL translation. I mean, we're able to handle everything: create a schema, create a table. This is something you'll see at the demo, which I'll do in a moment. You'll see how that operates and how simple and straightforward it is. So we perform that whole operation, and we're ultimately able to replicate that DDL change over on the Redshift side. Now, there will be a webinar coming up that will go into a bit more detail about how the DDL translation works, and also what the DDL translation is capable of doing, because it doesn't just make that decision about handling, you know, the DDL, you know, adding a column, removing a column, etc. Within an analytics environment, you want to be very careful about making changes to your target data, because you know, that may be critical for your analytics. You know, what happens if you are performing queries and you delete a column and your queries actually rely on that column, and maybe that information is useful. Conversely, if you add a column, what is that going to do to the analytics if potentially that changes the model of behavior, the information that is returned for your analytics queries? So maybe you want to say an explicit default value. You know, maybe in some situations actually, you know, you might be creating tables and you might be creating data on your source system, but you never want the table to be deleted in your analytics platform without you manually doing it. You don't want the replicator to automatically delete it, because someone could accidentally delete you know, years worth of information over on the Redshift side, and you want to be able to disable that. All of those options are available with the DDL translation. So the DDL translation does translate DDL, but it also makes you enables you to configure what your default and what your table and schema specific response is to particular operations, right? So that you don't have to perform deletes. You can archive tables, you can create copies of tables, etc., automatically as part of that DDL translation process. So anyway, that's coming up in a future webinar. I don't know when that's going to be yet, but you know, look out for that if DDL translation is something that's important to you. So the single schema replication, again, this is actually something that we've been doing for some of our customers for some time, and let me just paint the background scenario, right? So it's very, very common for many of our customers. You know, they have they themselves are offering another application onto their own customers. And in each case, you know, they have multiple customers, or maybe they have multiple projects. The schema in each of those projects and each of those customers is the same, right? It's the same application. It has the same table structure, has the same columns, the same rows, etc. Only the data is different because of obviously the customer environment. But in essence, the schema is identical across all of those different applications, all of those different projects, whatever the division is. But when they want to do the analytics, they want to be able to look at all of those. They're trying to concentrate the data from their 10, 50, 100, 1,000 customers and perform analytics over that entire data set. But they don't want to lose the ability to have a look only at one particular customer, or maybe only a particular group of customers. So what we do, what we can do, and what we've enabled now as just a standard feature of the replicator, and this works for Redshift, also now works for Vertica. We take that information, and you can see here we're taking out row-based information. That's what that little table is down here on the left-hand side. And what we do is we add the source database name to every row of information as we put it out. Now, this is something I've mentioned and talked about before. This is now just a standard part of the replicator. So we're taking the schema name from the source. It could be the schema name from a single database instance, or indeed multiple database instances that we're replicating together. We add the schema name as a new column to every row of incoming information of every table, right? And because we add that new column, we add that additional column of information into the process. We take all of that information and we replicate. We then replicate and we ultimately write it into a single schema on the other side. So we're not taking the USA schema and writing it into a USA schema over in Redshift. We're taking the USA schema and writing it into sales. We're taking the Japan schema and writing it into sales. We're taking the UK schema and writing it into sales. And then when it gets over into that side, obviously because we've appended the schema name to it, customer can go in and they can perform analytics, and they can perform analytics over the entire data set, which is going to contain USA, Japan, and UK, or they can go in and say, only show me Japan and UK, or only show me UK, because they've got the schema name, you know, the source from where that data came from in its original form. This does require some changes to obviously the way Redshift, the Redshift applier works, because that materialization process, we now have to take account of not only the primary key information, but all the database name information, which is why it's actually a slightly more complicated process. But it is now available and it's there. So you want to concentrate that information down, you know, from multiple different identical schemas, and ultimately write it into a single one. You know, we obviously are now able to support that within the replication process. That single schema, you know, replication into a single schema, like I said, we've been doing it for some customers for some time, and it's something that we increasingly see as a useful feature, useful requirement that you know, lots of customers will be looking for. So with that, you know, I want to return now. Let's go in and have a quick look at a demo. And what I want to be able to show you here is I want to show you, you know, what replication looks like, how it operates. I've also got the new DDL translation tools enabled on here, and so you know, I'm going to be able to show you exactly how this works. So let me just go in and have a look. I want to show you that over here, right? So I have a Redshift over here on the right-hand side. I have a MySQL database over here on the left, and we're replicating between them. So I want to show you here on the right. I've just done a select. I'm trying to look for data in a table, and not even the schema exists, let alone the table within the target database system. If I go over here onto the MySQL side, so what I'm going to do is I am actually going to create a new schema within MySQL, and I'm also going to create a new table. So I've now created a brand new table. You can see it's just got 2 columns, matches actually that demo of the single schema earlier. And now what I want to do is I want to go ahead and let's insert some data into this table. So I've done 3 things here, right? I've created a new schema, I've created a new table, I've inserted some data into it. Behind the scenes, I've got 2 replicators running. One replicator is obviously extracting the data from MySQL. Another replicator, which is actually local here, it's on a virtual machine here at the office, is actually taking that information and ultimately uploading and applying those changes into Redshift. So if I go into Redshift and have a look at it now, this is the point at which you do a live demo and you discover that something is not going to work just because you know, you happen to be doing a live demo, and in typical fashion this obviously is not going to work for me right now. So actually my replicator has just gone offline because I lost connectivity off to Redshift temporarily. So if we go in and have a look now, right? So okay, so you know, there we go. I've just put the replicator back online again. So here we go. What we got here is you know, behind the scenes, the replicator has gone ahead. We've actually replicated the DDL, so we've actually created the new target table. Here, we've taken the target table and we've actually applied the DDL. We've created a matching table over here on the Redshift side, and this has taken account of things. So it does have you know, primary key, semantics, etc. We've moved the table across. What I'm waiting for now is I'm waiting for the batch to occur. There we go, and the data has appeared across over on the other side. So you can see here, right? We've actually done the entire process here. I have created a schema, I have created a table within the MySQL, the DDL translation system has then created that information within Redshift, and ultimately we've inserted the data, and you can see it occurs over here on the other side. And you can see, very, very simply, I mean, obviously I'm replicating data between the two databases, but also you can see that, the information is going in. Let's just see if I can quickly add a new column into here, into my source table here over on MySQL, and hopefully we'll see this get replicated over here on the other side. We're just waiting for this to apply, and let's just see if we can get this to appear over here on the other side. And no, my replicator has just decided it's lost connectivity to the database again. I was going to do a status. No, I can't. Taking a long time for that to. Okay, we'll skip that for the moment. Live demo always going to be a problem. You can never guarantee it's going to work when you want it to. Okay, so you can see that we've created a table. We've replicated the DDL. We've replicated the data. We've got the data over here into the other side. You can see how the basic operation here works. We'll have a look. We've got upcoming webinars. We've got upcoming webinars on the DDL translation. We have upcoming webinars as well. We'll go into a bit more detail about how you can use the information in Redshift and how that operates. So you can see we got a basic operation there, right? We got the data. We did the basic DDL translation. Okay, I couldn't get the one part of the demo to work, but such is the life of someone who does webinars for a living. So you can see that we got the data and how easy and simple it was to get that data across and how it was working. So hopefully you've seen now, we can get the data into Redshift. Obviously inserting one row into a table is not particularly impressive, but we can certainly do that with multiple rows, multiple databases, multiple bunches of information, and get that across. You could also see that, on the whole, obviously, how relatively quick that was. It was a few seconds from me running the commands on the MySQL side to them appearing on the Redshift side. And that's an example of just how quick the replicator is. Typically, we measure latency even into Redshift, and even with the process of uploading into S3, etc., is going to be measured in seconds and usually sub-seconds, particularly once the tables, etc., have been created. So what are we doing for the future? Well, one of the things we don't do at the moment is we don't actually fully support SSL within the Redshift applier. So that means that we are not natively speaking to Redshift over an SSL connection with the replicator. And that is something that obviously we want to change because we understand that that's important to people. And obviously there are going to be improvements to the way DDL translation works. At the moment, DDL translation handles a whole bunch of different scenarios, but every now and then you come across some new one. Where somebody wants to do something slightly different, or maybe they want slightly different behavior and a slightly different response to specific situations. Obviously, we'll work on that one and try and determine, exactly how we can fix those various things. We will permanently be improving upon that. And obviously, we know, at the moment it works with MySQL and it works with writing to targets Redshift. And Vertigo, and even actually it works with MySQL if you want to make changes from one schema to another with MySQL. We will obviously be adding Oracle, and we'll be adding different targets as well in terms of how that works, and also just different behaviors into how it works with Redshift so that we can make better use of the Redshift environment. Also, more generally with the replicator, we're adding new filters. We're always trying to add new functionality into the replicator to make it more practical. So, maybe you want to be able to automatically hide credit card numbers. Maybe you want to translate between different types. Maybe you want to, merge external information that you might have traditionally done with, like row merges, etc., over on the target system. All of those things are things that we are constantly working on the replicator, and are always trying to add new filters to make it more accessible and more useful as we go forward, particularly for these heterogeneous type deployments. So, you know, if you're interested, right, if you would like to get in touch, you would like to, you know, maybe what you've seen is so interesting to you here, you want to get in touch with us and see about maybe potentially doing a POC, maybe you've just got additional questions, you know, feel free to contact us on the email address that's here, sales@continuent.com. You can also obviously go and have a look at the documentation. Documentation contains a load of information on you know, how to configure things, how things work, how things operate. You know, obviously, as I said at the start, you know, this is being recorded. All of our past training and webinars are available. We have our Tungsten University YouTube channel. You can go on there and find recordings of all of the stuff that we've done before, and learn about how the different components and the different bits and pieces work and how to deploy them and how to use them. All of those things are available. Obviously, also, if you want to get in touch, right, you know, feel free to email me direct. I'm always happy to answer questions. You know, always happy to you know, help people, you know, maybe understand the product better or understand what it can do. So that's it. That's the end of the webinar. I have actually run out of time. That little blip with the demo there probably didn't help. Hopefully you found it really, really useful. You know, thank you for listening. Thank you for joining. Please do attend our upcoming webinars. We always have a training Tuesday. We always have a webinar Wednesday. Contain loads of information about what we're doing. And, you know, keep using, keep watching, and, you know, keep talking to us about what it is and what it is you want from the product and the functionality. Thank you very much for your time today. And I hope you have a good rest of your day.